Good morning, everyone. This is Petals for your troubles, back with a new problem for thermodynamics. This one's about a commonly used method of fastening. One part of another is called shrink fitting. A steel rod has a diameter of 2.0026 centimeters and a flat plate contains a hole whose diameter is 2.000 centimeters. The rod is cooled so it fits the hole. When the rod warms up, the enormous thermal stress exerted by the plate holds the rod securely to the plate. By how many Celsius degrees should the rod be cooled? Now let's dive into this, shall we? Petals for your troubles, watchers. I'm pretty sure all of you remember how to use the gas or the given asked solution answer formula. Let's dive into that. So, first, we have the given. We know that we have a steel rod whose diameter is equivalent to 2.0026 centimeters and a flat plate, which the steel rod is supposed to go into, that has a diameter of 2.00 centimeters. Let's just write down the given. So we have the steel rod and the flat plate. Right. Keep in mind that what happens after the given is asked. Keep in mind, since we're dealing with a linear expansion, we have the alpha of steel, which is equivalent to 12 times 10 to the power of negative 6. There we go. Keep in mind, alpha is a constant depending on what type of metal you're using. So since we're using steel here, that's what the alpha of steel is equivalent to. Let's just give our numbers some units as to what they correspond to for our solution. So as you can see, the steel rod is LO and the flat plate is L. Alpha is 12 times 10 to the power of negative 6. And what we're asked for is the change in temperature. The type of solution we're using is the linear equation, which is L minus LO equals alpha LO times the change in temperature. Now, we are looking for the change in temperature, so we're going to try and manipulate the formula. We know that delta L equals L minus LO. Therefore, 2.000 minus 2.0026 is equivalent to delta L. So, for a change in L, we are given negative 2.6 times 10 to the power of negative 3 centimeters. So now that we are given the change in L, we can manipulate our formula by doing delta L is equivalent to alpha LO times the change in temperature. And now that we're given the change in L, we can finally isolate the change in temperature by dividing alpha LO to itself and bringing it to the other side. Now we can finally say the change in temperature is equivalent to delta L over alpha LO. And by plugging in the numbers, you get your answer. Now we're just plugging in all the given units that we have. We have the change in L, which is negative 2.6 times 10 to the power of negative 3. Divide that with alpha LO, which is 12 times 10 to the power of negative 6 times 2.0026. Adding in all the numbers, you are given an answer of negative 108 degrees Celsius. Just to be sure that you guys don't get the wrong answer, and I here shows you that the negative sign indicates that it is shrinking.